Newton's laws. So basically, this is on the application of the first and second Newton's law, as well as we know that the third Newton's law is more of which knowing. Because anyway, well, the third Newton's law tells you that every time you exert a force on something, that something also exerts a force back, and the magnitude would be the same but opposite in direction. For the first and second Newton's law, it's very important for you to use the free body diagram. Okay, so the free body diagram allows us to determine unknown forces, the acceleration or the masses, and an object that does not accelerate is in equilibrium. So when we say not accelerating, actually there are either at rest or moving with constant acceleration. So just try to remember that if an object is not moving or not accelerating, it means that the object is either at rest or moving with constant acceleration. So in this particular case, forces are balanced. So what do we mean by if it's balanced? Well, net forces is equal to zero. So that means, again, I could emphasize this one further, that this F net here means sum of all forces. So therefore, it doesn't mean that you don't have any force acting on your object. And actually, that is just the first Newton's law. And in this particular case, again, the object is not accelerating. So acceleration is zero. But then again, if the acceleration is zero, it only means that it's either at rest or moving with constant, no, not constant acceleration, but constant velocity. Okay. So constant velocity, at rest or constant velocity. So actually, we call this one as equilibrium problems. So to solve equilibrium problems, these are the suggested strategy that you can do. So first things first is you need to ensure that the object is in equilibrium. So again, no acceleration. It's either the object is at rest or constant velocity. Constant velocity. Because in most cases, in a particular question, doesn't necessarily be using, you don't have to use the word the acceleration is equal to zero. They will just say that the object is at rest or the object is moving with constant velocity. Well, that would be falling in this particular case that the acceleration is equal to zero. So the net force is equal to zero. And the next thing is you need to identify the forces. So we talk about this one, the common forces that you'll be encountering. So these are, it could be normal force. Okay, it could be, again, some of the common forces. You have Fn, you have Fg, it could be friction, and it could be force of tension. Well, and could be, yeah, these are the common forces that you'll be encountering. Normal force, weight, frictional force, and the tension. Okay, so make sure that you know on how to identify them. Again, in a particular question, they will not tell you that this is the normal force, this is the weight, and this is the friction, and this is the tension. So it's up to you to identify these particular forces. And you need to draw, this is very important, to draw the free body diagram. So make sure that you know how to draw a free body diagram. Okay, and of course you determine the forces you need. And for two-dimensional uh, problems, make sure that you try to break them down to summation of all the forces along x and the forces along y. Okay, so remember that force or forces are vector quantities. So therefore, you need to do or apply vector addition to them, or vector subtraction. So how do we add or subtract them? Again, we can only add vectors of the same components. Again, usually we call them x component or y component. So we can only add forces all along x and all forces along y. And to get the resultant, again, we just use trig for that one. If fx is not equal to 0, or the summation of all the x component is not equal to 0, as well as the summation of all the forces along y is not equal to 0, that means that your force would be lying in between the x and the y axis. So to solve for the magnitude of that, we use the trig, okay, or the Pythagorean theorem for that. And then for the direction, we solve for the angle. And lastly, you need to check your answer if it has the right units. Again, forces, it's given in Newton. So make sure that, and sometimes you solve for the acceleration. So therefore, acceleration has a unit of meters per second squared. And for the mass, it should be in kilogram. Okay. So any question on this part here? Well, again, this is just the suggested steps or strategy, you may say. But again, we have been doing this one even when we talk about vectors in the past. So, but here specifically, uh, if you can see, F net means summation or the sum of all the forces. So we're adding forces. So that is why we went back to our vector addition, wherein we try to take all the forces along x and all the forces along y. Okay, so let's take the first example here. Marlo is trying to lift up a 20-kilogram box by applying 80 newtons, so up, the direction is up, but the box does not lift off the ground. Determine the normal force exerted on the box by the floor. Okay. So for application, especially for the first and second Newton's law, it's very important to start with the free body diagram. So free body diagram will identify the forces acting on a particular object, but our object here is the box. So therefore, we're gonna concentrate on the box. So free body diagram of the box. So that means our object is the box. So again, how do we draw the free body diagram? You just represent the object as a dot. So this is my box. Now, we try to look at the situation here. It is lying horizontally on the ground, but you're applying a force upward, okay? And the mass of the object is 20 kilograms. So now, I mentioned last time that an object on the Earth's surface is always acted upon by the force of gravity. So I know that there should be gravity, which is downward. So again, this is just the weight, okay? So here I can say mass times g. That's the formula for the weight of an object. So 9.8. So this should be 196 newtons. Well, the direction is down. Okay. So now, what else? Well, if you can see here, I apply a force upward. So therefore, there must be an upward force. Okay. So I can call this one as my FA, applied force, which is upward, and the magnitude is 80.0 newtons up. Okay. So the question is, what would be the normal force exerted on the box by the floor? Well, from that question alone, that gives you an idea that, well, is it not that I mentioned last time that any object lying on a particular surface, once that object exerts a force on the surface exerts back a force. And that particular force is what we call the normal force. So there must be a normal force, the force exerted by the surface. So it should be going up also. Okay? But that is an additional force aside from your applied force. So this would be your normal force, and that should be a question mark. Okay? So this would be your free body diagram of the box. You have normal force, the force that you apply, and gravity, or the weight of the object. It's downward. The normal force and applied force is both upward. Okay. Now, in the question here, we're given that the box does not lift off the ground. So what does that tells you about the state of motion of your object? What is the state of motion of your object? The object is what? This statement here, what does this tell you about the state of motion of your object? The object is, anyone?
It's not being moved.
It's not moving, or it is at rest, right? So it is at rest. So now that you identify that it is at rest, so this should be falling upon this particular case. This is an equilibrium problem. So since it is at rest, that means that the forces acting on the object, if I'm gonna take the algebraic sum, it gives me 0. Okay? So therefore, I can use that particular expression, that the net force is equal to 0 in this case. So net force is equal to 0. So now, again, when we talk about net force, it tells you the sum of all the forces acting on that object. And if you can see, what are those forces? Well, you go back. This is the purpose of having the free body diagram, because the free body diagram tells you the forces acting on the object. So again, our object is the box. So what are the forces acting there? Well, you have there two upward forces, which is given by the normal force and the applied force. And you have a downward force, which is given by this one here. Okay, which is given by Fg. So it's downward. Both are upward. So if we're gonna expand our expression for the net force. Again, this net force here is just the sum of all the forces acting on the object. And again, the free body diagram will help us identify the forces acting on our object, as well as actually its sign convention. So if I can use upward as my positive, so that means that the normal force is plus. So you have plus Fn, and then plus the positive of Fa, and then plus the negative of Fg. And again, the algebraic sum of this is equal to 0. Okay? So again, this is coming from the upward forces. Okay? So these are the upward forces. That's why, again, the sign convention is plus. The other one, which is the weight, is negative because it's directed downward. Okay? So now we substitute our values. Well, Fn is a question mark, so that means that is just Fn. Then plus, that's 80. Okay? Plus, plus the negative of 196. Again, that's negative because it's downward. It's down. Okay? So it's equal. Again, the sum of all of this will give you 0. Okay? So now, if I want to solve for Fn, that means I need to isolate your Fn. That means that Fn should be in one side of my equation here. So it's either on the left or on the right. But anyway, I'm gonna make Fn stay at the left. So what would I do? Well, these two, 80 and 196, are just numbers, and I can combine them because anyway, they have the same unit. Okay? And remember that they're of the same component. It's just that 80 is up, that's why it's positive, and 196 is negative because Fg is directed downward. So if I gonna add these two, so again, Fn would be, this would be negative. So just the sum of 80 and 96. So positive 80 plus negative 196. That gives me negative 116. Okay? Negative 116. That should be equal to 0. But I'm solving for Fn. That means Fn should be on that particular side only. So I need to add both by 116 and plus 116. So if I'm going to do that, I can have my Fn on one side, and this will give me 116 Newton, and the direction would be up. Okay, so the normal force in this particular case is equal to 116 newtons upward. Okay, so if you can see, this is also another case that an object has a normal force not equivalent to the weight of the object. Because remember, you're trying to lift it upward. You try to exert an additional force upward. So you would expect that the normal force would be less than compared to your weight or to the weight of the object. Okay? So the floor now, instead of exerting without your applied force there, and you just let the object stay on the, or the box stay on the floor, that would be the normal force is equivalent to 196. However, with the application of additional 80 newtons, okay, or the force exerted by Marlow with 80 newtons. But remember, 80 newtons cannot lift the object because, well, you can see that 80 is just less than 196. The minimum force that you need to lift an object should be equivalent to its weight. So in this case, well, it's not moving. So if it's not moving, it is at rest. And if it is at rest, the net force is equal to 0. And if you can see here, you have actually three forces acting on your box. You have the normal force, or the force exerted by the surface. The second one is the applied force by Marlow. And the third force is gravity. Okay, so any question with example number 1 before we proceed? One. Okay, so we can move on. Example number 2. Again, hopefully you can reconcile this, that the net force from the net force is equal to 0 going to the second row, like expanding. I'm just expanding here the forces. Again, F net means taking the sum of all the forces acting on the object. So the second step would be just expanding or identifying the different forces. But then again, if you're going to do that, you just try to remember that forces are vector quantities. So therefore, we have to be specific with our direction, upward or downward or left, right. In this case, well, the forces are just lying on the same component. So therefore, you can add them all together. But taking note that upward is positive and downward is negative. Okay, so in this particular case, if you can see, Fn is a positive number. So that tells you that the normal force should be directed upward, because a positive calculation would give you a direction of upward. Okay, so again, in the calculation here, it will just come out naturally, whichever is the direction of the force that you are trying to solve. So if I get a negative value here, that means that, well, the force that I'm trying to solve has a direction opposite to the assigned positive direction. Okay. So let's take number 2 here. Okay. Determine the unknown force if the mass does not accelerate. Okay. So the mass does not accelerate. So talking about this object. So again, the key word there is that if it does not accelerate, net force is equal to 0. Or if you can see here, I have some forces that is angled off. So that gives me an idea that this would be pertaining to two-dimensional forces. So net force is equal to 0 also means that the net force along X is equal to 0 and the net force along Y is equal to 0. That means that if I gonna take all the forces along X and I take the sum, it should give me 0. As well as if I gonna take all the forces by vertical forces or along Y, the sum will give me equal to 0. So looking at our drawing here, so I can just draw my free body diagram in this case. So I will have my object, this one here. Okay, so now what are the forces acting on the object? Well, actually, this could also be taking note as the. So you have this one here, which is denoted by F, but this could be easily just be the weight of the object. Okay, this should be the weight of the object. And then what else? You have the force from the string. We can call this one as the tension force. Okay. The magnitude is given by this one here. And then we have the other force. It should be, remember, just go back to the definition of the different forces. Remember that the direction of the tension force is parallel, but away from the application of the force. So since we are talking about this object here, so that means that when we talk about this tension, so it should be away, again, away from the object, and it's parallel. So that's why the arrow would be here. So in that direction, okay, the arrow is here. And as well as for the other one, the arrow would be going away, because that's how we define tension, right? So now, these two forces here will have two components, like the F on the right side, given by the red. Is it not that you can break this one down to your Fx? So this is your Fx. Maybe I'll just gonna call this one so that I have a distinction. This should be 2. So this would be 2x. And then vertical component of such force. So this is my F2y. Okay, so F2, since again, if I'm gonna have an invisible y and x axis there, this particular force is lying in between, because the angle there is, you have a given angle. So therefore, it's not lying on the y-axis alone or the x-axis alone. So it has two components, the x and the y. Okay, I mean the x and the y component are neither non-zero. Both are non-zero. So that's for F2. I'm just going to call the other one as F1. Okay, so now I can also break this down to its x. Again, both x and y component are non-zero in this case. So that would be going to the left. And then you have the y component of my F1. So this would be my F1x. And then this is my F1y. Okay. So F1 and F2 will have two components. Well, for my F, since it is just lying along the vertical axis, that means that the x component of my F is 0. So again, this is one of the things you call quadrantal angle, because your F is in the y-axis. So the x value would be 0 in this case, but for F1 and F2, if you can see, both are non-zeros. So the question here is, we need to determine the unknown force. You want to get the unknown force. The unknown force is given by F. Okay? So what must be this value here? if the object doesn't accelerate. Again, you can also think of this one as the weight of the object. The object would be having a weight that is directed downward. So how will we solve for that? Well, if you're going to examine F, the known force F, so if you're going to take note, a known force F on the y-axis, right? So F is lying along the y-axis. Remember that again, I can somehow have or can write this would be my y-axis. So this would be my x-axis. So if you can see that one there, F is just solely, it's just solely lying in the y-axis. But since it does not accelerate, that tells me that the net force along y is equal to 0. So therefore, I just have to concentrate because anyway, F is lying along the y-axis. So therefore, I'll just have to take note of all the forces along y and equate it to 0. Since, again, it is not moving, it is not accelerating, the sum of all the forces is equal to 0. So now I'm just going to examine what are these forces. What are these forces along y? So I'm going to examine. Well, you have for 1. Again, that's a purpose of having your free body diagram because you can see that 1 is you have F that is downward. This is along the y-axis. And if you can see here, well, this line is just parallel to this line. So therefore, that is along the y-axis. So you also have 1, F2, which is upward. Remember, the direction is upward. And you have F1y that is also moving upward. So along the y-axis or the y components of the forces, you have 3 forces, F1y, F2y, and your F. So again, going upward is positive. For example, you're going to take the upward direction as positive. So that means that I have positive F1y, then plus the positive F2y. Again, both are positive because if you can see the direction of their arrows, it's upward. Okay? It's upward. And you have F plus the negative of F, negative since it is downward, and then the sum of everything is equal to 0. So that means that if you're going to take the algebraic sum of F1y, F2y, that would be plus the negative of F, that should give you 0. Okay? So now, if I'm going to solve for F, all I need to do is identify what would be my F1y and F2y. So to solve for F1y and F2y, those are just the components of your F1 and F2. So now you go back to what you have known about trig, because always if you're going to break down your vector into its x and y component, you will always create a right angled triangle. So this is just a triangle, right angled triangle there. Okay, the 40-degree angle is here. So if this is 40 degrees, it also follows that this is 40 degrees. Actually, yeah, because the angle, the total angle here is 90 degrees. So therefore, this is 50, the complementary of 40 degrees. So if this is 50 here, so if this is 50 degrees, it also follows that should be 40 degrees here. And this is also 40 degrees. Okay, so again, just try to remember the triangle. Triangle will have a total sum of 180 degrees. But if you have a right angled triangle, one of its angle will always be 90 degrees. So that means that the sum of the remaining two angles, which are acute angles, the sum would always be 90 degrees. Or the two angles are just complementary with each other. Again, the sum is 90 degrees. Okay, so therefore, I need to know my y component and my x component. So what I'm gonna do is I'm just gonna break down my f1 to f1x, f1y, although I don't have to necessarily do the computation for f1x, but that would be an additional example in breaking down the two components, because sometimes you'll be solving forces along x. So this is also how you do it, if ever. So f1x is just f1. So if you can see, this is the adjacent side. f1x is the adjacent side. So it should be cosine 40 degrees. Cosine 40 degrees. So that would be f1 is 1.0 times 10 to the power of 2 multiplied by cosine of 40 degrees. And if you're gonna solve for that, oops, let me check the value of this one. That would be 100 times cosine of 40 degrees. Oops. 40 cosine times 100. So that's around 76.6. Okay. But this should be negative because the direction is to the left. However, it doesn't matter in this particular case because you're just going after with the y component. f1 sine 40 degrees, so this should be 1.0 times 10 to the power of 2 sine of 40 degrees. So that should give me an answer of 40 sine times 100. So that's around 64.3. Okay. So that would be my f1. And for my f2, so again, I can break it down to f2x and f2y. So f2x is just the x component of my f2. And if you can see, that is the adjacent of 40 degrees. So it should be cosine 40 degrees times f1. So this is 1.0 times 10 to the power of 2. And cosine of 40 degrees, well, it should give you the same answer, but this one is 76.6 plus, because it is to the right. The f2y would be just equivalent to f2 sine of 40 degrees. This is 1.0 times 10 to the power of 2 sine of 40 degrees. So the answer should be the same value of that, because anyway, f2 is the same. You have sine 40. So this is 64.3 newtons. Now you just have to substitute this to your values here. This is f1y. So that means that you are substituting this value. So this should be 64.3 newtons plus 64.3 newtons plus the negative of F is equal to 0. So again, what I did here is just substituting the values. So this one, substituted here, and again, your F1, okay? So if I gotta take the sum of these two, that should give me uh, 128.6, 128.6 plus the negative of F. Oops. F. But then again, if I gonna move this one to the other side, I mean separating my F with the number 126, that should be plus F plus F. So the answer would be F is equal to 126. 28.6 newtons or 129 newtons. Well, from the direction, it should be down. So that would be your F. Okay, so any question with this one here? So it's not always that you'll be solving for the y, but maybe sometimes you'll be asked to, what do you think would be the other force along x this time? Well, I would say that the x component, even though, let's say for example, I get this value here, 76.6 newtons. Even though I'm not trying to calculate using the values that I have here, automatically, even though I don't have the value of my F1, I would say that the value of my F1x is also 76.6 newtons, but it is to the left because there are only two forces along x. There are only two forces along x. And again, the net force along x is 0. So therefore, it follows that F1x and F2x have the same magnitude. So that would be a variation to this particular question. Like, even though if I don't know F1, but I know, let's say, for example, what is my F2. So right away, I'll have the x component of my F1, which is 76.6. And if I know the angle, I can use trig to solve for the magnitude of F1. Okay? Any question with this one here?
Yeah, I have a question.
Yes. Yes.
So when you're finding the components for F2, why did you use F1 cosine 40?
Oh, that's my mistake. Sorry. It should be F2. Sorry. Thank
Okay.
you for that. Yep. It should be F2 also. It should be F2. Okay. Thank you, Valia. Yeah, it should be F2. So whatever is the subscript there, you should the same subscript. That's the rule. So yeah. Although in this case it doesn't matter because anyway, F1 and F2 have the same magnitude, right? But that's a wrong practice to do that, even though their magnitudes are the same. Okay. Any questions so far? Uh, hmm. Okay. Can you answer example number 3?
Mr. V,
Yes.
did we have to find the x component, or did you just do it as an extra step?
Yeah, well, I just did for an extra step, but you don't have to do in this particular problem. I just show it that you can break it down to x and y. But the thing here, since I know that the forces or F is just along the y axis anyway, so that means that I only have to deal with the net force along y.
Okay.
Essentially, you can disregard the x components in this particular question. I just show it that again, just an extra, yeah, extra work you would say, but also showing you that in a case wherein you don't know F1, even though you just given F2 here, well, right away you can use that information that your X component, the net force is also zero. So that means that if I know that F2X is 76, so right away I also know that F1X is 76, but in the opposite direction.
Okay.
Yeah.
Thank you.
So yeah.